Hi, everyone. Thank you so much for joining us today for our December webinar in January. We postponed it last week because we were having some computer issues, but we are happy to be with you today. We're going to be talking about data collection for different equipment and what you might need as far as data for an ROI calculation. And of course, with us today is our Mid-Atlantic Regional Manager from SEPCO, David Brewer. David, thanks so much for taking the time to do this webinar with us today.
Thanks for having me. I look forward to it.
Awesome. Well, before we get started on the educational content and everything, I wanted to ask you why is this kind of information and being really specific about getting it and getting everything that is needed so important?
So Lori, there's really three answers to that. I mean, data collection in terms of trying to make recommendations is gold. I mean, the more information we have at SEPCO when we make recommendations, the better off we are in making the correct recommendation for our customers. Two, it protects the distributor, whoever we're working with, and if they give us all the data that's available, and we're able to make those proper recommendations, it protects them as far as hey, we make the recommendation. It's on our backs that we make the right recommendation. And three, on the data collection for the ROI, it justifies our existence in these plants, and be able to it also helps us with credibility. So all that said, we're going to go over all those data points right now and talk about that.
Fantastic. Well, again, thanks for joining us. Let's get started with our housekeeping slide. Basically, if you've been with us before, you've heard this, but for those of you who are new, SealConnect Classroom is our educational webinar series that are presented by SEPCO experts, but also other thought leaders in the industry. We're very proud to have other people join us for our webinars, and we're happy to be able to provide this educational content for our community. If you want to join us on social media, you can use hashtag SealConnect. Please, on the right-hand sidebar, there's a place where you can ask questions. Please ask questions throughout the webinar. We will answer all of them at the end, but if anything is particularly pertinent to what David is talking about, I might jump in and go ahead and ask him ahead of time. So please ask questions. This webinar is being recorded, and you will get an email of the recording and the slide deck within 24 hours of the webinar, so sometime tomorrow. And reminder again to just ask any questions you have as we're going through, and we'll let David kick it off.
Thanks, Lori. Appreciate it again. So again, my name is David Brewer. I'm the Atlantic Regional Manager for SEPCO. Basically, I spend my time from Delaware down to Jacksonville, Florida area, through the I-95 corridor of Georgia. But I work with a lot of distributors up and down the East Coast and help solve problems. My background, I've been in this business since 1996, and before that spent 4 years in the Navy and graduated from Lee's McRae. So I have a long history of working with what we're getting ready to talk about today. So our agenda today is what we're going to talk about is equipment data and features, meaning one of the things that we provide to you guys out in the field is data collection sheets. And so what we look for is measurements, process conditions, things of that nature. We want to know about environmental controls. We're going to talk about that. And last but not least, we're going to talk about data for an ROI calculation. ROI standing for return on investment. That is directed to the end user of that equipment, the owner of that equipment. And what that does is that justifies our existence in these plants. It helps us with showing them the reason they're using our products or anybody's products is so that they, they can show a good return on investment. And then we'll have a case study that shows you exactly how to use that data. So information for equipment, from equipment, there are, what we're going to specifically be talking about today mostly are seals and mechanical seals and mechanical packing, and the data that's involved in collecting for those specific products. But what we're looking at when we go into the field is we look at pumps, we look at mixers, we look at agitators, rotary airlocks for that matter, valves, screw conveyors. There's different types of equipment, and we want to be very specific when we talk to engineers and talk to regional managers like myself, that we are specific to those pieces of equipment. What are we looking at? Are we looking at an agitator, or are we looking at a pump? So those are the things that we're going to be talking about and being very specific to those. So our basic data. Again, what type of equipment is it? Is it a pump? Is it a mixer, an agitator, etc.? Sometimes, we have huge databases at our company, and those databases will mostly have this information already in it. We collect that data and then we bank that data. So there's a lot of times where we can help you with your data collection, but we need to know what type of equipment is it? Is it an agitator? What is the manufacturer? For instance, if it's an agitator, is it a Lightning? Is it a ProChem? What type of manufacturer is making that equipment? Then there's a serial number. Typically, if it's not too old and it's not too worn down, there will be a serial number associated with that piece of equipment. It's always helpful to get us that serial number as well. Sorry. Because that serial number can help us determine what we're looking at. And then the model number. The model number is very important, specifically to pumps. If you look at your slide there, you're looking at typically looks like what might be typical Gould's pump right there. Those types of model numbers are very important to us. Is it a 3196? Is it an MT? Is it an ST? Is it an LTX? The frame size helps us a whole lot. So that type of data already starts us off in the right position. So then again, looking at a data sheet, we want to know, what size, not only what size pump is it, but what size shaft is it? What size, what are we looking at? Are we looking at a shaft with a 3-inch sleeve or 3-inch shaft, or are we looking at what type of pump is it, or what type of equipment is it? And we want to know specifically the size of that. The shaft speeds, that's very important, because we want to know what type of material are we going to recommend to you. We want to make sure that we know that we're making the right recommendations regarding shaft speeds. Everything from packing to mechanical seals has limitations, and we want to know what type of materials we want to be able to select to you. Speeds are very important, because if you could imagine, if you have a shaft that's turning, let's say 3,600 RPMs, that's very fast. And if we're recommending packing at that point, we want to know what material, like it eliminates a lot of different packings that we manufacture out there. So we have to be very specific on shaft speeds. And then the size of the pump, that goes without saying. All right. Dimensions for an RFQ. Again, these types of data sheets are something that we can get to you. But everything on a data sheet it tells a story. Again, I mentioned shaft or sleeve OD, stuffing box bore, that's very important. Stuffing box depth, stud size. All these are very important. And when we're talking about mechanical seals and packing, these are the kinds of things that we need to know, so that we can protect you, the end user or the distributor, in making the proper recommendations. But all this data is very important, and this helps us, because the more data that we have, the less questions that we have for you going down the road. one of the things is, as you can see here, if everybody knows how to read a schematic or read a drawing, you'll be able to see the data points here that are so important. If you look at, this schematic here, what you're looking at is, we want to know, for instance, if we have a mechanical seal, can we fit that mechanical seal in that piece of equipment? Can we fit that bearing isolator in that piece of equipment? What kind of packing would go in this? What kind of cross-sectional packing could we put in this piece of equipment? All of that, all of those data points are very important for us, and we're very interested in whether or not we can be able to put, just from an engineering standpoint and from a physical standpoint, can we put our mechanical seal in there? Can we put the packing in there? Can we put the bearing isolator in there? Those are very important data points for us to understand. Equipment features. So one of the things that you'll notice out there, and you already know, is that these things, there's so many different types of equipment out there. For instance, a split case pump or horizontal pump or vertical pump, they're all different. Is it an in-suction pump? Is it a rotary lobe pump? Those things are very important for us to know. We want to know, what kind of wetted metal parts are there in that pump? Is it a titanium or Hastelloy? Is that something we need to be concerned about? Does it have a cooling jacket or not? Does it, because that's a whole different type of mechanical seal arrangement that we would put in there if it did have a cooling jacket. Has the equipment been altered? This is probably one of the most important things that we need to know out in the field, because when we get all of our data back, if that information on paper is not the same as what is out in the field, I can't tell you how many times that we've been, that we've made a recommendation looking at a piece of equipment on what it should be versus what it really is out in the field. And what happens is, equipment gets altered all the time. They turn down a sleeve because of, for instance, in packing, people will turn down a sleeve because of packing wear, or they will bore out a stuffing box because of packing wear. And when they do that, when they bore out a stuffing box, or when they turn down a sleeve, it changes the whole physical dimensions of that stuffing box. And so we need to know, has that stuffing box or has that piece of equipment been altered so that we can make the proper recommendation? The other thing is, when you look at use, is that piece of equipment continually being used? Is it 24/7? Is it on when they turn it on? Does it not go down until there's a cold mill outage? Or is that application intermittent? Excuse me. Does it run, stop, run, stop? We'll make a different recommendation based on that as well. So when we look at pressures, we want to know what is the suction side, and on a pump specifically, what is the suction side looking like? What is the discharge stuffing box or stuffing side looking like? The stuffing box in the seal chamber, we need to know what the pressures are there. The reason for this is because, as you're going to see in the next couple of slides, environmental controls are very important to us. That means, like, we want to know what what we can set the flush pressure at, what we can set the if we're putting an air seal on it, what can we put the air pressure on, things of that nature. But the suction, discharge, and stuffing box seal chamber pressures are extremely important to us. Fluid characteristics. Again, when we're making recommendations, we need to know, what is that product being pumped? What is that product being agitated? What is that product being conveyed, or what have you? We need to know what is the concentration. For instance, in acids, as everybody, as people probably tuning in know, acids change from how much dilution rate that acid is at. What is the purity of that acid? What type of acid is it? What is the concentration of solids in that process? Because especially in a paper mill, we need to know, are you at a 4% consistency, a 3% consistency, whatever it might be. But all that concentration and what is the product being pumped, we need to know those things. That is very important for us. So the fluid characteristics, this goes along with the concentrations and the product being pumped, but we need to know, for instance, what temperature the product is. What is the process temperature? The reason for stuff like this is, believe it or not, acids act differently at higher temperatures than they do at lower temperatures. Viscosity changes at higher temperatures versus lower temperatures. So the higher the temperature on a product, the less viscous it could potentially be, or the lower temperature, the higher viscosity it could be. It could crystallize at a certain point, things of that nature. Temperature is very important for us. The pH value, the pH range is from 1 to 14. 7 being very neutral. We need to know 1 on the high, the high acidity side, or 14 on the high caustic side. What are we looking at when we look at the pH range of a product? The specific gravity, that's how heavy a product is. If you're moving something out of a big tank, we need to know what the specific gravity of that material is. Water has a specific gravity. Different types of products, gypsum, things of that nature, have a different specific gravity. So we need to know that specific gravity when we're making recommendations. The fluid characteristics, we kind of touched on this a little bit, but are solids present? What kind of viscosity are we looking at? What kind of grit, grind? Mud has a different viscosity, or chocolate has a different viscosity, say, than water does. We need to know what kind of solids are present. Does that fluid have a tendency to set up or harden if it gets cool? For instance, black liquor in a paper mill, as soon as it hits atmosphere and gets cooler, it starts to set up. It gets very, very sticky. We need to know that. Does it crystallize? When you look at certain applications, there's calcium for instance, in water. You would think just standard water wouldn't offer many problems, but depending on what type of minerals are in water as it's being pumped, you get crystallization across the seal faces when we look at that. So we want to know, does that have a tendency to crystallize once it hits atmosphere? Is this fluid toxic? Meaning, like, if it gets to atmosphere, can it harm a human being by either burning their skin, or if it's an inhalant, if they can hurt them that way? We need to know that. We take specific precautions when we look at that type of information. And is that fluid corrosive? Here recently, I was working on an application where we had to go from a stainless steel part to Hastelloy, because the product being pumped was so corrosive, it just ate right through stainless steel. And not just ate through it, over a 6-month period, but ate through it in a very short time. So we need to know, what is this material that we're looking at? Is it corrosive against stainless steel? Is it corrosive against titanium? Not only that, but we have to look at the elastomers that we put in our mechanical seals and the seal faces. Are they compatible with the material that we are sealing? That's very important. In most of our data sheets, you will notice, on a very typical RFQ, something that you would fill out to send back to SEPCO, it has all those questions on it, and it has a spot where you can fill that out and send it to us. Like I said, the more data is gold to us. So the more data we have on an RFQ, the better off we are. The more protected you are, and that, hey, look, I gave you that data. You had this information when you made this recommendation. That's very important. We need to know these questions are very important. What happens is, if we don't fill this out early on in the process, it becomes a guessing game, and it becomes a series of questions back and forth that we have to ask to make recommendations to the end user. Environmental controls. So when we were talking about pressures earlier, and when we were talking about what is the material that you're pumping or agitating or moving. It becomes very, very important because we want to know, can we use a clean liquid? Is there a clean liquid available? If the flush is a water, can that water, is it compatible with the process that you're handling? But do you have a clean flush available? If not, what is it? Is it river water? Is it potable water? Is it non-potable water? Those are the kind of things that we need to know. When you look at quenching a mechanical seal, sometimes, for instance, that very same application that I was telling you about, where we had to go with a Hastelloy sleeve, we could not introduce a clean flush water or any kind of flush for that matter. So we had to quench the seal with steam. And in order to do that, we need to know, is that steam available to be able to quench that seal with? Is cooling water available? So if you have a boiler feed pump, for instance, or a super hot application where you have to have a cooling jacket, can you pipe in cooling water? Can you pipe in cooling water to a seal reservoir, a seal pot for that matter? Or do you have a seal? Can you buy a seal pot to put there? All this stuff is very important for us to know. Is the system cleaned in place? We call it CIP. Excuse me. But cleaning in place is very important. Sometimes you'll do an acid clean in place, or you'll do a steaming in place, SIP. And that's really important. And we need to know, when you steam in place or when you clean in place, does the pump continue to run, or is it shut off? The reasons we ask those questions is for a mechanical seal, we need to know, those answers for balancing information, for our seal faces. Are we making sure that the seal faces don't open up when we do something like that? Or if that acid that we're cleaning in place with, is that compatible with the materials that we've recommended? So after a specific excuse me, I'm so sorry. After all the data that you've been giving us, and and we made a recommendation, and once we put our solution into the process, we want to know, we need to know how to make a calculation on a return on investment. How much longer is our product or your product lasting versus what was in there before? What is happening with that process? Are we adding value to that process? So I'm going to kind of go over a few things with you there as well. So with new technology comes, obviously return on investment. So the return on investment is a calculation of a monetary return of any project. So the ROI reports is often persuaded the purchase. That's how we get somebody to try something new that's out there in the field. And through that, if we're lasting longer and we're actually improving life and improving conditions of a piece of equipment, we need to know how to calculate that. So the data that we collect here is also just as important as the data that we collected in making a recommendation. So we want to know, again, what was leaking out? Was it leaking to ground? How much was leaking to ground? How much was leaking from the into the process? So for instance, if you had an evaporator pump in any mill, actually, whether it's a paper mill or a chemical processing mill, if you were introducing water to a process, that water then had to be evaporated off of the process to finish the process, we need to know how much was going into that. How much flush was going into either a set of packing or a mechanical seal, and then having to be evaporated off that process. We need to know, was that product being diluted by an external flush system? If it was being diluted, how much does that cost the plant, and how much does it hurt? We need to know exactly, when they take the data from that dilution rate and then they send that to the wastewater treatment plant, how much does it cost to clean that process? Treatment's a very important thing. You wouldn't believe it, but I have often had people, talking about not wanting to put a flush system onto a pump because the treatment alone costs too much money. And when it goes to sump and when it goes to the sewer, there's a cost associated with that. So we need to know, what is that? All these data points are very important. And one of the things that we do right now, I'm working on a project with our director of mechanical seals at SEPCO. We are working on a project where we're looking at, we're talking to both the planners, we're talking to the environmental engineers of the plant, we're talking to the production managers and everything to find out all of these data points that we can come up with a proper return on investment for recommendation that we've made. Resources. So when we look at all this, everything costs. When these plants are running, or your plant is running, everything has a cost associated to it. Everything. And if it's not there locally at the plant, it's typically maybe even at corporate where they have costs associated with everything. So from everything from energy, energy costs money. That involves evaporation costs. When we look at energy, that's one of the very specific things that we look at are what are your evaporation costs? Air, gases. Believe it or not, air, there's a lot of money associated with air, and then gases, because not all the time, if we make a recommendation where, hey, here, an air seal is the best solution, there's either costs associated with air, or they can't use air and they have to use something else like nitrogen to purge a mechanical seal or purge an air seal with. Oil lubricants, gosh, I can't tell you how much money is involved in using for a bearing frame to keep it lubricated properly. And if you're keeping it lubricated properly and you're keeping contaminants out, what is the cost associated with that? And then loss of product. One of the things that's so, if I go into any plant I've ever been into, whether it's a paper mill or chemical plant or phosphate mine or what have you, look on the ground. You can see that there's either piles of stock, there is product from on a chemical plant. You can see product on the ground, plastics, styrene, things of that nature that have been lost just by seeping out from whatever process it is. It's whether it's the pump, whether it's a mixer, an agitator, a conveyor. If you see product on the ground, there's a cost associated with that as well. So the process cost, we've got our own figures that we've come up with when we do an ROI, when we do a cost analysis for an end user or customer. We actually have an app that we use. It's a vendor verified app where we look at, we kind of know the cost of certain things, but we verify that with the end user themselves. So we'll take the product life that you had in there before. If it was a mechanical seal that just wasn't lasting, and we've come in and we've doubled that life or tripled that life, there's a cost associated with just whatever the product life was. Did we outperform what we replaced? That's a very standard thing. Then there's downtime. Not only did we outperform what was there, but the downtime and lost production. What does it cost for a paper mill or a chemical plant or a phosphate mine? What does it cost them if they are unexpectedly down? Is there a cost associated with that? Lost product from leakage. Again, we've had a lot of different statistics given to us or numbers given to us of what does that product cost that's sitting on the ground, that's not being able to be used anymore. What is the cost associated with that? And then the contamination. Where does that fit in? Because a lot of times, if you're leaking from one section to another section, product contamination is a big thing, and we've seen that over time. Specifically, if you're using, I'll give you an example. If you're using a double seal, and you have to have a barrier fluid in between that double seal, and you are using something that's not compatible, which we've seen hundreds of times in the past, and when that inboard seal fails, whatever's being used as a barrier fluid is going into the process, and that is defined as contamination. That contamination, you have to take care of that contamination. There's a huge cost associated with that as well. We want to know that so we can help calculate the return on investment for whatever recommendation that's been made. Equipment service. There's a huge cost with replacing a pump or a mixer, a rotating element, bearing frame. There's a huge cost associated with that. It varies from plant to plant, but there is a cost associated with that. What is the downtime of efforts? What does it cost for a mechanic to come off of one job and go to another job unexpectedly to have to work on something else? There's a huge cost association with that as well. Inventory management, that's a big one, because so often if you see, because of a piece of equipment failing so often, there's huge inventory on the shelf for that piece of equipment, because they're just used to it failing, more often than not. And so, because it's a problem child, and it is, you've always heard that saying, 80% of the problems in a mill or plant are associated only by 20% of the equipment. So there's more inventory for that 20% of that equipment in a facility than there would be for a piece of equipment that's never a problem. And so we want to be able to manage inventory better. If we can solve the problem, and if we can get all the data points that are needed to solve a problem, we can come back with a better recommendation and a better return on investment. So I'm going to give you a quick case study. There are many out there to use, but this is one. And this comes specifically from a pulp and paper plant where there was just excess water leakage from the paper machine pump, and it was in a brown stock pump. I'm going to give you these data points, and then you can, if you have any more questions, I can go over other applications as well. So these numbers are what happened before we made any recommendations. It's just a large stock pump. There was roughly, what we gathered, 4.23 gallons per minute, which was leaking out of the stuffing box and onto the ground and into a sump. It actually clogged the sump itself, so that was another problem. But it equalized, or it equaled about 2 million gallons per year for this one pump. So if you took a 365-day window, snapshot at this one piece of equipment, about 2 million gallons were leaking on the ground a year coming out of that. The sewer cost per gallon, which was verified by the plant, was about 0.13. So that was the cost of per gallon to treat that. So at about 2 million gallons times 0.013, you're looking at about $27,000 a year in just sewer costs alone. So $27,000 loss. So water loss to the process causing the dilution was about 1.5 gallons per minute going in, which equaled about close to 788,000 gallons per year. Which is, again, that's all diluting, that's all going into the process where they were trying to bring this water off this process to make paper. So the total cost there, the water cost, again, verified by the plant was only about 0.0036 per gallon. So it wasn't a tremendous amount of cost per gallon, but if you added it up, over time, from about 800,000 gallons a year times the 0.0036, you had about $2,838 just associated with dilution rates. So the new system, we recommended a better packing, what we thought was a better packing, a new lantern ring that we would put in there. Also in this, we added installation instructions, proper installation instructions, but with that cost alone was just about was only about $1,200. Then the the water loss to the drain was eliminated by being able to recommend a better packing that we could tighten the gland follower tighter on. We knew that the packing that we put in there transferred heat better, so it would allow you to do this. So we were able to take that water and decrease that water rate to about 262,000 gallons instead. So we were able to save about $945 just from eliminating to the drain. The total cost of the new system for the first year was about $2,178. So we were able to save a lot of money there. But now adding all this up, and this was signed off on by a high-ranking official in the plant. If you took the total cost of the existing equipment and the new technology cost, or minus the new technology cost, the total losses per year were roughly $30,000. So only considering the water loss alone, we took the ROI equaled out to be $30,000 minus the $2,000 savings that we just shared with you a little while ago. It's about $27,991. Go to the next slide and kind of, whoop, I'm sorry, back that up, my fault. I kind of got ahead of myself there. So if one of the things that we did was we wanted to make sure that the total cost, I botched that a little bit. The total cost of our total water savings was about $30,000. That was our total water savings. The cost of the products were just over $2,000. So our overall total savings was $27,000. That was the savings that they were able to sign off on, and those were hard dollars that we were able to show them for just this one piece of equipment. Now, if we did a survey on all the equipments, if we added that up, remember a paper mill, decent sized paper mill has thousands of pieces of equipment that we could do that on. But that was actually signed off on by a high-ranking maintenance superintendent. So there you go. You guys have any questions? I know Lori's coming back on. Lori, sorry for kept getting a little frog in my throat there while I was going on and on. So
no, that was fine. You weren't going on and on. That was great. And I want to point out, just as a heads up, that savings, that $27,000 savings, that was just for year one. So
yes,
those savings were going to continue to build on itself. And then, I don't know how many Brown stock pumps are in a plant, but a lot, I'm assuming.
No, that's a very good point. That was just year one. Absolutely.
Yeah. So great. Please remember that you can ask questions. We have a couple that I'll go ahead and get started with. Thank you again, David. David's contact info is on the screen. So if you want to connect with him on LinkedIn or email him, feel free. We still have time. So if you want to ask any other questions, please do so. But one question that has come in is, so measuring stuff can be tedious, and people may want to take shortcuts. Well, I know this pump and these are the measurements, but as you said, if it's been altered or you know, if any little thing is different, that can affect how the equipment itself functions, but also any seal technology that's put in. So how do you encourage a team to be diligent in getting measurements? Because you know, just using the typical measurements from the pump that was installed 10 years ago or 5 years ago may not be accurate anymore. So how do you encourage your team to really get those measurements as precise as possible?
Yeah, no, that's a great question because I mean, being in this industry for as long as I've been, you know, nobody likes to, you know, get sweaty and go in these plants and actually have to put their hands on stuff a lot of times. And so just giving you a pump model or, you know, what it was, like you said, 10 years ago, sometimes seems to be a shortcut, but we've all heard the term, you know, measure twice, cut once. And it just, I can't tell you how many times I've seen it that the better, more current data that we have, the more successful that we are. It helps everybody to look better if we know that we've got the right information in front of us when we're making a recommendation, and it makes us look better. It makes the customer look better. It makes the the end user look better. It makes the distributor look better. It makes everybody look better. If and that it helps with the more current data that we have, the less questions that we're asking and bothering somebody with.
And ultimately, it's saving time for the end user at the plant and our engineering team or whoever is designing or helping spec the technology that is being installed.
Correct.
Great.
Absolutely. Yep.
Okay. One more question so far. So so the data sheets, however you want to say the word, data, tomato. Are the data sheets different for different seal technologies? Are there specific information that's needed for a bearing isolator versus an air seal versus a mechanical seal? So,
Yes,
and
absolutely.
how do you know what you need?
Yeah, well, one of the best things to do is, for us, you can go on our website and most of that information's there within the product information. But yeah, absolutely, there are, there's different information we need for a bearing frame for a bearing isolator versus a mechanical seal for a pump, or a stuffing box dimensions for a set of packing. There is definitely different dimensions that we need, depending on the technology and depending on the solutions that we're seeking to put in.
And so, where do you recommend people go to get the data, the RFQ or the data sheet for each specific type of technology?
So you can, you can either email me and I could get you the information that you're looking for, or if you went on our website at www.sepco.com, all that data in there, the products that you're looking for, whether it's a mechanical seal, a set of packing, bearing isolator, most of that information is on our website.
Okay, I do not see any more questions coming in. So I think we're going to wrap up unless anyone has one. I want to remind everyone that this is the December webinar. Our January 25th webinar is going to be on simple field tests you can do on pumps yourself without having a lot of expensive technology or anything. And that'll be Chris Tyndall, January 25th at 11. Please go to our website and register. And David, thank you again so much for doing this webinar. It's been a great one. And thanks for being flexible with our timing to you and our attendees. And we will see you guys on January 25th with our next webinar. And if you have any questions you didn't get to ask or think of anything, email David. His info is at the screen, or you can email me at Lori, LORID, @sepco.com. And we look forward to seeing you in a few weeks. Have a great day.
Thank you.
Thank you.
All right, bye.